Hello. In this section of the video, we're going to be looking at annuities. An annuity is a level stream of cash flows at equal time intervals. So an example will be mortgage payments or car loans or any loan that requires you to make the same fixed payment every single period until it's done. Now, the annuity formula makes use of the payment function in the time value of money formula in Excel. So we are going to start doing that. Let's do it using examples. And the textbook I'm using is the Intermediate Accounting textbook by Spiceland et al. So first question, Rita Grant wants to accumulate a sum of money to pay for graduate school. Rather than investing a single amount today that will grow to a single future value, she decides to invest $10,000 a year over the next 3 years in a savings account paying 10% interest compounded annually. She decides to make the first payment to the bank 1 year from today. So, what does this look like visually? I'm going to draw a simple timeline. What I'm going to do first is put some space here before I get to the calculator. So let's insert some space, and then I'm going to draw the timeline. So she is going to be going to graduate school. I think it's in 3 years. We have a time 0 and n is 3 years. That much we got from the questions. She decides to invest $10,000 a year. So in year 1, she's going to put away $10,000. In year 2, she's going to put away $10,000. And in year 3, she is going to put away another $10,000. So 3 payments. The rate of return on the savings account is 10%. It's compounded annually. So here is our thing all done. We want to know how much she will accumulate at the end of the 3 periods. What we want to do is calculate the future value of each and every one of these payments. The future value of the 10,000 in year 3, add that to the future value of this 10,000 that will grow for 1 year from year 2 to year 3, and we're going to add that to this 10,000 that will grow for 2 years. It will grow from year 1 to year 3 to tell us how much will be in the account at the end of the period. Sounds complicated, doesn't it? Well, let's simplify it, because we could do the future value calculation here using a basic Excel future value calculator. Now I'm going to hide these tabs here and go back to my formulas for future value. So let's hide. And then I'm going to erase the timeline that I did. I thought hiding those columns will hide the timeline, but it didn't. Here is the future value calculator that we've done from the basic calculator section, the one we built in person. We want to invest an amount. The rate per period here is 10%. The number of compounding periods is 1 because it's annual compounding. The number of years is 3. Notice that this is the future value calculator because we're calculating future value. Payment per year, she's going to invest $10,000 a year. So I'm going to treat that investment as if it was an outflow. She puts away $10,000, $10,000, $10,000, and then she gets a lump sum amount at the end of 3 years with all the interest she's earned in the interim. So we're going to put that in as an outflow. There is no present value because right now today in the account she has $0. So What is the future value? It's 33,100 using the future value calculator. This is an example of what we call an ordinary annuity. An annuity that starts in the next period. So for this problem, Rita put away $10,000, the first payment starting a year from today. In other words, end of period 0, beginning of period 1. She did the same here. And then she did the same here. Now, the second question says, treat question 1 as if it was an annuity due. There are two types of annuity in Excel, in finance. We have ordinary annuities and annuity due. With ordinary annuity, the first payment starts in the next period. With an annuity due, the first payment starts immediately. So if we draw a timeline for the annuity due problem, what you end up with is Rita putting away $10,000 today and $10,000 a year from now, and the third $1,000 payment happening in year 2 so that she can go to graduate college in year 3. If you look in here, the first amount begins immediately with an annuity due, whereas with an ordinary annuity, the first payment begins up one period from now. What is the difference between the two? Well, all else being equal, the future value of an annuity due is higher than the future value of an ordinary annuity. The first $10,000 payment will grow for 1 year, from year 2 to 3. The second $10,000 will grow for 2 years, from year 1 to 3, and the final one will grow from 3 years, from time 0 all the way to time 3. Whereas in the top value with the ordinary annuity, the first payment doesn't have time to grow, the second one grows, the third one also grows as well. So all else being equal, an annuity due is worth more than an ordinary annuity. Same with the present value. The present value of an annuity due is worth more than an ordinary annuity. Now, how do we make this difference in Excel? Here is where the type comes up. I'm just going to erase this timeline because there's no other way to get rid of it that I can see. So, if you look in the calculator here, we have a type function. If you omit the type, Excel takes it as an ordinary annuity. You can omit the type or put 0 for type, and Excel treats it as an ordinary annuity. For an annuity due, type is 1. When type is 1, can you see? It pegs that the future value of the payment is higher than when type is 0. So when you omit type, Excel defaults type to 0, which is an ordinary annuity. Ordinary annuities are more common than annuity dues. Okay, so again, 0, it's worth 33,100. If it is 1, it will grow to 36,410. Question 3, Rita Grant wants to accumulate a sum of money to pay for graduate school. She wants to invest a single amount today in a savings account that is equivalent to 10,000 at the end of each of the next 3 years. Now, this is saying to you, not how much will this money grow to in the future, but it's saying what is equivalent to putting $10,000 in an account every single year. So we want to figure out the present value of the $10,000 payments. I'm going to unhide and bring up my present value calculator. I am a bit slow here today, aren't I? Oh, wow. Okay, that's better. So let me hide everything and give you only uh, the present value calculator. For this problem, we're dealing with question number 3, by the way. She wants to know what single amount she can invest today that is equivalent to $10,000 for the next 3 years. So we're looking for the present value of this $10,000 payment. Again, amount per annum is 10%. Number of compounding periods is 1. Number of years is, we've got 3 payments. The payment per year is 10,000. I'm treating it as an outflow. It could be an inflow. There is no future value in this calculation because the only cash flow we're accounting for is the annuity. And type is 0 because it's ordinary annuity. The present value of this payment is 24,868. And if we treat it as an annuity due, by changing that to 1, it is slightly higher. So here is our lump sum value equivalent to the $10,000 a year. They're both annuity dues, and it's also equivalent to the future value. Can I show you that? Let's find the future value of our present value payment. If I use the future value formula, rate is 10%, as we said. The number of periods is 3. The payment amount, we're going to treat it as 0 because the $10,000 a year is equivalent to 27,355 lump sum. So we can't put in present value and the $10,000 a year. One or the other, they're equivalent to each other. So 0 for payment, and I'm going to use the present value amount instead. So I'm putting it in because I'm going to select it from here and say, or I could have typed it. It would be minus 27,355.37. I'm selecting the value where it calculated because there are some zeros in there. There's some decimal points in there. And the other thing I'm missing out now is type. We know type is 1 because type is 1 here, type is 1 here. We can find the equivalent amount. Press enter. Can you see the future value is exactly this? So 10,000 per period is exactly equal to 27,000 present value and a future value of 36,411, as long as they all have the same type. How about we have a look at a couple more questions? Question 4. Assume that you borrow $700 from a friend and you intend to pay that friend in 4 equal installments. So here's my nice little picture. I borrowed $700 today. So I received $700 today. It's an inflow to me, but I have to make 4 payments. Cash flow payment 1, cash flow payment 2, cash flow payment 3, and cash flow payment 4. Each of these cash flows are equal, which makes it an annuity. And also because the time periods for the payments are equal. I'm making it at the same time every single year, and I'm making the same payment. So an annuity is a level cash flow stream that is expected at equal time intervals over a number of years. So says the rate of return is 8%. Future value is 0 because in this problem you assume that once you pay off the $700 in equal installment, you will owe nothing at the end. So the future value in this problem is equal to 0. So what is the cash flow payment? The formula to use is the payment formula in Excel. I'm going to scroll down a little bit and show you what I mean. Down here, I have an equal payment formula, PMT. It helps you to calculate what the cash flow is if you have an annuity problem. Okay? So what is that value? Rate per annum is 8%. This is an ordinary annuity. It doesn't say so unless beginning 1 year from today. It does say so. 4 equal installments beginning 1 year from today. So that is an ordinary annuity because the first payment is due 1 year from today. There is only one compounding period. It's annual compounding. Number of years is 4. The future value of this transaction is 0. The present value is 700. Type is 0 or omitted. And this tells us that at a rate of 8%, you can pay off this bill at $211.34 every single year. That payment is equal to the $700 plus 8% interest over that time period. And the last problem we have here is one of leases. That's a very good use of annuity in Excel. On January 1, 2021, the Stridewell Wholesale Shoe Company signed a 25-year lease agreement for an office building. Terms of the lease call for Stridewell to make annual lease payments of $10,000 at the beginning of each year. So $10,000, very important. Beginning, it's an annuity due, with the first payment due January of 2021. So first payment is due exactly the first day of the lease. Assuming an interest rate of 10% properly reflects the time value of money in this situation, how should Stridewell value the asset acquired and the corresponding lease payment? Well, if you value the lease, you have the value of the asset. We know that the lease is a 25-year lease. So here's what the timeline would look like. We go from period 0 all the way to period 1, all the way to period 25. I put a break in the timeline to show you that the cash flows in all of the periods from period 1 to 25, it's identical. There's no additional information by drawing 1, 2, 3, 4, 5 up to 24 because every single time it's $10,000. So 10,000 here, 10,000 here, up to period 24. We have 25-year leases, so we have the first payment up to the 24th. So I will put something in for year 24. So year 24 is when we have the last cash flow payment and nothing happens in year 25. So first payment today and 24 more payments make 25. How do we put this into a calculator and make this work? So first thing I'm going to do is delete all the inputs to my calculator. I'll start with the rate per annum. 10% reflects the time value of money, so I'm going to use 10%. It's annually compounded. Number of periods is 25 years. The future value is 0 because once you finish paying the $10,000, that is the end of the lease. The lease is not worth anything else to you at the end, so that's 0. The present value of the lease is what we're trying to calculate. I'm sorry, we're using the wrong calculator. We're calculating the present value of the lease, what it's worth today. So wrong calculator, I need the present value calculator. So bear with me while I delete this and copy the calculator so it's on the same level with our problem and I don't have to scroll up, okay? So what I'm going to do is I'm going to copy the present value calculator, this one right here. For some reason, oh, there we go. I'm going to copy this calculator, Control C, and put it here. Now, I'm only copying this for convenience because I'm teaching and I want you to see the formulas I'm using on the same sheet. You would never copy your calculator to reuse. You just use the same one that you have. You can copy it, but it's very inefficient, as you can see from the way I'm doing it. I'm hiding everything so that you can see my present value calculator. So you wouldn't copy. I'll show you a better method in a minute. So rate per annum is 10%. Number of compounding periods is 1. Number of years is 25. The payment per year is 10,000. The future value is 0 and type is 1 because it's an annuity due. The value of this 25-year lease today is $99,847.44. If Stridewell was to put the value of this lease on its balance sheet, it would record it at $99,847.44. This ends our introduction to how to use Excel for time value of money problems. In the final video, I am going to talk you through a calculator that I've built. So you can use the calculator to perform all of the calculations in here. It combines all of the functions into one in Excel and just shows what you can do in Excel with all of these calculators. See you in the next and final video.